Okay, so we've got the circular function definitions, the trig functions. Now let's look at those and see how those definitions can tell us what trig functions are positive and negative in which quadrants. First of all, r, radius of a circle, it's always positive. X and y, they can be positive or negative depending on which quadrant they're in. So if we look first at quadrant 1, we know all the points in quadrant 1 have a positive x value and a positive y value. Now you'll notice how I color-coded these to match the x's and the y's up here as well. In quadrant 2, all the points have a negative x and a positive y. In quadrant 3, all the points have a negative x and a negative y. And in quadrant 4, all the points have a positive x and a negative y. Now, by looking at this positive, negative, the x and the y values in each quadrant, we can determine that in quadrant 1, all 6 trig functions are positive. Okay. R is always positive, x and y are always positive, so all 6 trig functions are going to be positive for any angle that falls into quadrant 1. In quadrant 2, you'll see that the x is negative. That means that the cosine function is going to be negative over positive, which is negative. Its reciprocal is going to be negative. Tangent is going to be positive over negative, which is negative. So is its reciprocal. Sine is the only one that's going to be positive. Well, that and its reciprocal function. A lot of times you'll hear me talk about the, these 3, because depending on the sign of these, the SIGN, of these, if this is positive, then so is its reciprocal. Its reciprocal doesn't change the, it doesn't change the positive or negative. So we get in quadrant 2 that all 6 trig functions are negative except sine and its reciprocal. For quadrant 3, that's negative, negative for all the points there. Then all the trig functions are negative except tangent and cotangent. That's because you end up with negative over negative, which is positive. In quadrant 4, all the trig functions are negative except cosine and secant. Okay. So what we can do is abbreviate this and just look at the ASTC. Okay, that all sine, tangent, cosine, and then just remember that if we're talking about sine being, positive or negative, then its cosecant, its reciprocal function, is going to have the same sign. All right, so real quick, we have these 2 words, which when spoken sound exactly the same, right? We've got sine as in plus minus, and we have sine as in the trig function. So sometimes along the way, you might hear me say sigan. It's not because I am incapable of reading. It is just my silly way of saying this word to emphasize if I'm talking about the sign of the sine function, I might say the sigan of the sine function. It's just my silly way of differentiating between those 2. I assure you that I can, in fact, read. And you do not have to drop the class now and go find someone smarter. All right, let's play a fun game called Name That Quadrant. Okay, so we've got the tangent is less than 0 and cosine's greater than 0. That's another way of saying tangent's negative, cosine's positive. So in which one of the 4 quadrants is the tangent negative and simultaneously the cosine positive? Now if you want, you can pause the video and see if you can do all 3 of these before I reveal the answers. So where's the tangent negative and the cosine positive? Well, the cosine's positive here on the all and here, right? The all negative except cosine. So we've got 2 choices, either 1 or 4. Now in which one of these that the cosine's positive, in which one of these 2 is the tangent negative? Well, here they're all positive, so it must be quadrant 4. Okay, so pause the video, see if you can do parts B and C. Do it. Pause it. I know you're sitting there just waiting. Okay, so tangent negative and sine negative. So in which quadrant are both of those negative? Well, the tangent's negative in 2 and 4. Here, the sine function's positive, so it must be quadrant 4 again. And then lastly, where the cosecant's positive and the secant is positive. Now, if the cosecant's positive, we know its reciprocal function, the sine, is also positive. If secant is positive, its reciprocal, or cosine, is positive. So in which quadrant are both sine and cosine positive? Well, the only quadrant where that happens is quadrant 1, where they're all positive. Okay, so, like I mentioned before, we can abbreviate this this quadrant business with this ASTC. I was taught all students take calculus. That was the way that I remembered those. A standing for all, positive. S standing for sine, being positive. T for tangent, C for cosine. You just have to remember the reciprocal functions are also positive. So even though this abbreviation just takes in consideration sine, tangent, cosine, you just have to remember their reciprocals. Sine's positive, cosecant's also positive. From this, we get the even and odd properties. Now, you might remember if you've had college algebra recently that even functions are symmetrical about the y-axis, whereas odd functions are symmetrical about the origin. We can see that more when we go to graph these functions later on. But for now, we just have that the sine function is an odd function. That means the sine of negative x is the same as negative sine x. Okay. We can kind of see that with the quadrant business here, that if you talk about, say, like a negative 30 degrees, that we end up with a 30-degree angle down here. So the sine function is going to be the same, but it's just as sine x, but just with a negative out front. The cosine function is an even function, so that means that the cosine of negative x is the same as cosine x. And then you'll notice that, these odd functions all have the same kind of property to them, that this negative comes out front. The even functions, they act the same, that this negative and this positive, that the function is the same, whether it's negative or positive. Okay, and then there's the symmetry I mentioned earlier. All right, let's find the value using the even and odd properties and the unit circle. So tangent of negative pi. Now you can totally use your calculator for this because this is a nice easy one, as you can see what the answer is going to be there, right? So the odd property tells us that this negative is going to come out front because the tangent function itself is an odd function. So we bring that negative out front. Then we do tangent pi. Looking at the unit circle, pi is right here at 180 degrees. Excuse me. My reference point is -1, 0. So my x is -1, my y is 0. Tangent is defined as being y over x. This negative right here carries over to right here. And then we get that definition of y over x, or 0 over -1. That's just 0, so -0 is the same as 0. Okay? So let's look at sine of negative pi over 6. One way, we can just use the even and odd properties. The sine's an odd function, so this negative comes out. And then if we look at the sine of pi over 6, using the unit circle, we know that the sine is y over r. In this case, because it's the unit circle, r is 1. So pi over 6 is right here at 30 degrees. My reference point is √3 over 2, 1/2. The sine being y, so that's 1/2, and then that negative coming from right there. Another way that you could do this is by using coterminal angles. You could say that negative pi over 6 is -30, which is the same as the coterminal angle of 330 degrees. So you could say that, hey, those two are the same, and then look at 330 degrees. Its reference point is √3 over 2, -1/2. So we know that the sine is y, so we get -1/2. Either way that you want to go about it works. Okay? All right. So next up, the secant of negative pi over 4. If we want to do that whole coterminal business for this negative 45 degrees, I just changed negative pi over 4 to degrees. I added 360, I got 315. So 315 is down here in quadrant 4. There's its reference point. The secant is 1 over x. So I'm not using the even-odd property here. I'm just using the coterminal business. So I get 1 over x. X is root 2 over 2. 1 over root 2 over 2. Okay, whenever you have 1 over something, that's the same as the reciprocal. So 1 over this fraction is this fraction flipped. So I get 2 over root 2, which I then have to rationalize. Means get that radical out of the denominator. So I multiply by root 2 over root 2. I get 2 root 2 on the top. Root 2 times root 2 is root 4, or just 2. Those cancel, and I get just the square root of 2. Now this is working toward something called reference angles, which if you've had a trig class before, you've probably seen these. You've been waiting for this moment, and here it is. We can relate all angles to a positive acute angle called the reference angle. Now remember, acute means between 0 and 90. Okay? So the formal definition of a reference angle, let's let theta be a non-acute angle in standard form that lies within a quadrant. Means it's not going to be on those axes there. Okay? That angle's reference angle is the positive acute angle that is formed by the terminal side of theta and the closest x-axis. So if my angle in standard form looks like this, where there's my initial side, and then my terminal side, let's say, is over here in quadrant 2. There's my angle. The reference angle would be made with the terminal side and the closest x-axis. The closest x-axis may be the negative or the positive. It just depends whichever one's closer to that terminal side. In this case, that negative x-axis is the closest. So this angle right here is called the reference angle. It's very important that you use the x-axis, not the closest axis. You don't want to use the y-axis. It's always made with the closest x-axis. Okay? So, let's find the reference angle for these. Yep, I'm going to cover this up, but you can see I've already got the answers out there. So, for 135 degrees, we know the angle in standard form is going to be over here. It's the initial side. Terminal side's over here in quadrant 2. If this is 135, then this angle right here is my reference angle. It's made with the terminal side and the closest x-axis. Now, how did I get 45 degrees there? Well, this angle right here is the rest of 180 degrees. If that's 135, this red angle is the rest of it that gets me to 180. So I took 180 minus 135 to give me that 45. 210 degrees, that terminal side lies in quadrant 3. So it's down here. Now, the closest x-axis, again, is this negative x-axis. So this little angle right there is my reference angle. Now, how did I know that was 30 degrees? Well, if this is 210, and we know this straight line right here, this negative x-axis is 180, what's the difference between 210 and 180? Well, it's 30 degrees. So you can see that reference angles might be the continuation, or they may have some overlap. See how that reference angle right there is actually part of that 210 angle? That's okay. 260 degrees. That angle is going to be from right here all the way around to right here, still in quadrant 3, just like the last example. Really super close to that negative y-axis here. Some students will mistakenly say, oh, that reference angle is 10 degrees. No. It's the closest x-axis, not the closest axis, the closest x-axis. So with this terminal side, this negative x-axis is closer than the positive x-axis. So this angle right here between 260 and 180 is 80 degrees. 359 degrees. That's going to be in quadrant 4. That's almost a complete revolution. Right? So it's going to be from here all the way around, almost a complete revolution. The closest axis right there is that positive x-axis. So this right here, that little tiny angle right there is my reference angle. And not that we really have to do the subtraction. I got a feeling you can do that in your head of, you know, the distance here between 359 and 360. That's 1 degree. Let's do some of these with radians now. Pi over 3. Now that's the same as 60 degrees. That reference angle, well, this terminal side, the closest x-axis is this positive x-axis. The reference angle is itself. That's because if this angle is already acute, remember, acute being between 0 and 90, if you're already in quadrant 1, the reference angle is itself. All right, 7 pi over 4. To start with, I think it's going to be easier for you guys to work in terms of degrees than radians. But certainly if you want to work with radians, that's awesome. Okay? I chose to just go ahead and change it to degrees to maybe make it a little easier for you. All right, so we get 7 times 180 degrees divided by 4. 7 pi over 4 is the same as 315 degrees. All right, so 315 is down here in quadrant 4. The closest x-axis is right there. It's that positive x-axis. That angle comes from 360 minus 315. That's a 45 degree angle. Now we could say 45 degrees or pi over 4, either one. That just comes from changing degrees to radians. Some of these I just want you guys to just memorize. Okay, it's just going to be a lot easier on us all if you go ahead and just memorize some of these like 30, 60, and 45 numbers, okay? Because those are going to show up more often than not. Negative 240 degrees. Now remember, it's negative, so it's going to be measured in, you know, in this clockwise direction. So negative 240 is going to be right here in quadrant 2. Its closest, right there, closest x-axis is that negative one. The distance between 240 and 180 is going to be 60. Now you'll notice I said 240 and 180. I could have said, you know, that distance between negative 180 and negative 240, and you have to subtract the negative and stuff, but you can really just look at it in terms of 240 and 180 and say, okay, that's a 60 degree difference. Now that you know that's the same thing as pi over 3. All right, this is going to be a little messier. 2.5 radians. Where in the heck is 2.5 radians? When you go to graph it, how on earth did I know that it was right there? Well, because I took my calculator and I took pi over 2, not 180, not 180 degrees, no, just pi divided by 2. 3.14159265359 divided by 2. You get about 1.57. Okay? Pi itself, about 3.14159265. Yeah. So 2.5 is between 1.57 and 3.14. So what's this reference angle right here? Well, it's that distance between 3.14 and 2.5. How did I know to subtract this way? How did I know not to go 2.5 minus 3.14? If I subtracted that way, I would have gotten a negative. Reference angles are always positive because they're acute. Acute angles are always between 0 and 90. They're always positive. So that's how I knew to do that. Okay, so here's what we're going to do. We're going to be able to use reference angles and these quadrant signs, SIGNs, to find exact values. Okay? So, for instance, the sine of 135 degrees. You could use the unit circle. You know, you find 135 degrees, find that reference point, use the definition of sine. Or you could say 135 has a reference angle of 45 degrees. That's the subtraction between these two. And then it's in quadrant 2, where the sine function's positive. So I get that the sine of 135 degrees is the same as positive sine 45 degrees. So you'll notice that there's two things here. I've got my reference angle and I've got the secant, right, the sine of, the sine function in its quadrant. So this SIGN, this positive, comes from the fact that the sine function is positive in quadrant 2. And then sine of 45 degrees is root 2 over 2. The tangent of 300 degrees. We could use the unit circle for that. Or, let's find the reference angle. 300 degrees is down here in quadrant 4. We get a reference angle of 60 degrees. That's the difference between 360 and 300. In quadrant 4, the cosine is positive, which means tangent is negative. So because of the quadrant, I get a negative here. And then my reference angle is 60 degrees. So you can see how I color-coded this. That blue negative here comes from the sine, the secant of tangent in quadrant 3. Quadrant 4, in quadrant 4, which is where this reference angle is. And then the tangent of 60 degrees is root 3. So I'm trying to color code this so you can see that the red stuff comes from my reference angle, the blue comes from the quadrant. Okay, last couple of examples. 4 pi over 3, if you want to change that, that's 240 degrees. So that's going to fall in quadrant 3, 240. The distance here between 240 degrees and 180 is 60 degrees. So there's my reference angle. Remember, don't do this reference angle with the y-axis. It's always made with the closest x-axis. In quadrant 3, the tangent function is positive, so the cosine is going to be negative. So I get negative cosine 60. These are the same thing. The negative is because the cosine function is negative in quadrant 3. The 60 is my reference angle. Now, we did the trig functions for 30, 45, and 60 before. So those are the ones, it is just going to be in your best interest to just memorize these. Okay? It just is. If you have to continually look them up, it is going to take you so much longer. I mean, yeah, it's true. You can just look them up every time. But it's kind of like trying to write a 10-page essay and having to look up how to spell every single word. At some point, that's going to take you a long time. So it's just going to be best if you just memorize these. So cosine 60 degrees is 1/2. That negative comes from the quadrant. Okay, last one. That is the secant of negative pi over 3. That's the same as negative 60 degrees. So that's down here in quadrant 4. The cosine is positive in that quadrant, which means its reciprocal function of secant is also positive. So we get that negative pi over 3, or negative 60 degrees. This is the same as positive, because of the quadrant, secant 60 degrees because of this reference angle. Now how did I know it was 60 degrees? Well, because that angle is negative 60. So the positive version of this angle is 60. Now secant of 60, remember secant is just the reciprocal of the cosine. And we said that the cosine of 60 was 1/2, way back up here. So we get 1 over 1/2, or 1 divided by 1/2. Remember how I said before that 1 over means reciprocal? So if I talk about the reciprocal of 1/2, that's just 2 over 1. Okay, so that concludes sections 7.3 and 7.4.